COVID year, who knows if we got to it. Summation of arithmetic and geometric series. There are formulas for these. I put them on the top of the warm-up so that way you don't have to get lost in your own little note packet to go find them. Summation of a certain number of terms for arithmetic series on the left, geometric series is on the right. So we're going to be using those two formulas. Now, let's say we're looking here at this one. So we wanted to evaluate that. What could I do? Well, I mean, Spanky's way, and he's not here to defend himself, would be to type it in the calculator and press enter, because you got the summation function in the calculator. Math, summation, boom, type it in. But if I wanted to use the formula, and if I wanted to know, well, how would I do this without writing out 25 terms and without using those crazy formulas that we worked on yesterday? 2i plus 7. That's a linear equation. Linear equations are arithmetic. And so arithmetic series, there's sums, we have that formula right there above us, which is, how do I write it up there? N over 2. N over 2 times A1 plus AN is how I find the sum. Well, A1 is your first term. The first term, when written in summation notation, you got to use your index number, because it's not always a 1. It could be a 0, a 2, a 10, or whatever. I put that in to get my first term. So I put 1 in. It gives me 2 plus 7 is 9. So A1 is 9. N is our top number. So N is 25. N is going to be 25 as long as this first number started with a 1. If this number was a 2 and I ended at 25, technically N represents the number of terms you added together. So that I technically would have 24 terms instead of 25 terms. I don't think I'd do any of those tricks to you. If I knew what AN was, I could just plug in. AN, in our case, would be the value of the 25th term. You get the value of the 25th term, put 25 in for I, and evaluate. 57. So we put all of that in to our equation here. And so this summation should be equal to N over 2, 25 over 2, times the first term plus the last term, 57. So we got a calculator, tell me what that is. And then we'll confirm that we did it right by doing the actual summation thing with the calculator. These numbers can get big. Ivan, what'd you get? 825? I mean, they can get big. All right, so now type it in using the summation thing on the calculator. Math, go all the way down, fill in all the boxes. You can use X's instead of I's and see if we get 825. 825? Bingo. Good. Got it. Done. All right, let's go to this one. Evaluate this. If you see the word evaluate, 98% of the time it's talking about a series. When you see a list of numbers, identify the pattern. What's my pattern? Divide by 2, that means it's what kind of series? Dividing by 2, we're technically multiplying by a half. You multiply by a half every time, that's geometric. If I constantly add and subtract every time, it's arithmetic. So the sum of a geometric series, now I know that some knuckleheads will come out, they'll continue this pattern on for 10 numbers, add them all up, and be done with it. But I could save myself time. Oh no, is it changing your schedule? I done lost my train. What am I doing? Sum. Geometric series sum of a finite number of terms is A1 times 1 minus r to the n over 1 minus r. A1's first number, so A1 is -2. R is what we times by 1/2. N, they tell it to me. I simply just plug all this madness in. So the sum of the first 10 numbers would be equal to -2 times 1 minus 1/2 to the 10th over 1 minus 1/2. Now, I'll tell you this. Back when we used to have the old calculators, so many people got this wrong because we couldn't type it in right. When you're using these, they have that fraction type function where you press the alpha button, y equals and enter, and it makes that fraction and it cuts down your mistake. So let's type this in, see if we all make sure we all get the same answer. So that way we're not a statistic in terms of people that got it wrong when they shouldn't have. Alpha y equals enter makes that fraction. I get -1023 over 256. Or -3.996. And you can always use 0.5 instead of 1/2. Yes? No? Quiet. Ivan, did you get it? No? Subscripts? What you talking about, Willis?
It's -3.996.
Alpha?
You just cleared it.
Alpha?
Alpha y equals
One thing like a 45%. And the 1 minus 0.5. Gives me that does for math practice and everything. Here's what I got. Y'all end up texting thumbs. How does somebody twice your age beat you on pressing the buttons with my thumbs? A foot for old people. All right. Phone for old people. Jerk. See this one. Skip around a little bit. All right. Evaluate a geometric series given the following. There's only one formula to find the sum of a geometric series, and that's the one we just used. A1 times 1 minus r to the n over 1 minus r. You look at what you got. I got r. I got A1. I don't know n. I got to figure out what n is. The way to figure out what n is, you got to use the explicit formula to figure it out. They started throwing all kinds of curveballs in here. So explicit formula A1 is equal to r, or A1 times r to the n minus 1 power. So -128 is equal to -2 times -2 to the n minus 1. I got to figure out what n is. Divide by 2. Was that 64? And you got to think a little bit. It gets a little weird when you got negative bases. What power do you got to raise -2 to make 64?
4.
So I figured that out. Negative 2 to the 4th power is 64. Then you solve for n. If 4 is equal to n minus 1, n is equal to 5. Boom. Plug everything in. We can all race Ivan again to see who gets the sum first. So negative 2 times 1 minus negative 2 to the 5th power over 1 minus negative 2. I gave him a head start, and I'll still beat him. Still beat you. Negative 22. I accidentally hit enter halfway through the problem. Boom for old people.
Yeah, well, let me.
What do you mean it won't let you do what I did?
Yeah, I'm getting error or whatever. You put parentheses.
You gotta,
You have to use the define it, not the parentheses.
yeah, there's a negative button in that for negative numbers. Probably the first thing.
Oh, I'm just now. Oh, yeah, negative.
Ivan, you still letting that phone for old people defeat you?
Wait, let me see how you're trying to type it. You want something like this.
You solved error. All right. You got your parentheses. Alpha, y equals, enter, and it makes that. And then put everything else in the middle.
Like order live. For live.
All right. Ooh, find in. Check this one out. With the given information. Now, I have to identify the kind of series it is, and I didn't write it. One thing is everything in this left column has been arithmetic. So I have to tell you, if I just give you a first term, a random term, and a sum, this is arithmetic. Huh? On yours it does?
Yeah.
So I fixed your copy, but not my copy. How about that? All right. So
No, the other one, no. The other three don't. Just that one. Just that one. The rest of them just say find it. No, we could solve one. That's only two of them have it.
all right. So this is these two stacked on top of each other, arithmetic, the ones to the right of geometric. So how would I find n with this kind of information? Well, we use our summation formula for arithmetic. Series. The sum of a finite number of terms is equal to n divided by 2 times a1 plus an. I simply just put the numbers in and solve. 3625 is equal to n over 2 times 25 plus 265. Solve for n. Ivan, I'll race you. Tell me when you're ready.
He said, all
All right, ready? Solve for n. Oh, it's 3625. You already messed up. You said 3-2. I'm trying to help you out.
Counting down.
Oh, you're counting down till I get to start? How much of a head start are you getting? I got 25. What'd you get, Ivan? Error message. What? You can't type that in like that. You got to solve for n. Oh, 3625 is equal to n over 2 times whatever that is, 6, 7, 8, 9, 290. Multiply 290 by half and then divide 30, 3265 by it. Man, let a little math one algebra equation take you down like that? With the calculator. All right, I'll let you redeem yourself. Find n for this one. Well, looking at the pattern numbers, -4, 16, -64, we're multiplying, it's geometric. Finding n, I see a sum value there. I'm going to write my geometric formula for a sum. A1 times 1 minus r to the n over 1 minus r. Find our information. A1 is -4, it's the first term. R is what I multiply by, -4. We're looking for n, we know the sum. -13,108 is equal to -4 times, holy smokes. All right, 1 minus -4 to the n over 1 minus -4. I got to solve for n. You want to raise for this one, Ivan? Step 1, divide by -4. Tell me what you get. -3277 is equal to 1 minus -4 to the n over, that makes 5. All right, multiply the 5 over. Oh, positive. Yeah. Multiply by 5. Yep, is equal to 1 minus -4 to the n. Subtract a 1. Divide both sides by a negative. And figure out what exponent power -4 is got to have to make -16,384. I'm gonna guess. It's a 7.
Yeah.
All right, that's a lucky guess right there.
I want to get something ridiculous like 28.
It's exponent powers.
Yeah, I know.
You get 4 to the third is 64, and then you go after that, you get 256. So you couldn't go so far to get into tens of thousands. All right. Let's do this one, and then we'll go to the next page. Yeah, there's another page.
Right, all past 215.
I know. Find n instead of saying there it is on the top. Ivan probably would just use his calculator and keep changing the value of n until he got it to match 55. Probably what he would do. I mean,
It's logical.
I guess if you're persistent enough, there's always a unconventional way. If I look at that function there, that's arithmetic. We're talking about a sum because I see sigma. So the arithmetic sum formula, n over 2 times a1 plus an, I'm solving for n. I know the sum is 55. We're solving for n. My first term is what I get when I put this index number in. So put 1 in, 4 minus 1 is 3. And then plus, now we hit this. We're like, what? What do I do here? What's an?
I think first respond.
Yeah. What's an?
One.
Nah, not 1.
Two.
Nope. This is the last number that you want to add up. I don't know what the last number is because I don't know what this number is. No, you take n, put it in where the k is. That's going to be what an is, be 4n minus 1. So that's what we're solving. You got 55 is equal to n over 2 times, what is that, 2 plus 4n? Solve for n. Multiply by 2, distribute the n, get everything on the same side. We'll divide everything by 2, try to factor this monstrosity. $55, add up to be 1. It's going to be 11.5 plus 11 minus 5. You had 2 options for n. Negative 11 halves, positive 5. Here's the thing about n. When it comes to series and sequences, they're counting numbers. What are counting numbers? Yeah, whole positive numbers. 5 is my answer, not negative 11 halves. So n is 5. Ivan's way might have been quicker. Yeah, but what if that top number had to be like 102? I know you sit there all day, be like, I'm not giving up on this problem.
Well, I mean, if you were to talk about it, you would have known like the first one was 3. 3 divided by 55. You ain't got to go that, or 55 divided by 3. You ain't got to go that far to figure it out.
Maybe, maybe not.
Not saying that's how I would solve it. It's kind of 55 divided by 3.
Let's see. We'll skip the top 2. Let's go to the bottom 2. And then we'll stop. So Jack Cook is tasked with stacking cans in layers such that each layer has 1 less can than the previous layer. This continues until there's only 1 can on the top. Basically, he's making a pyramid. You know, so if he had 4, then he's got 3, then he's got 2, then he's got 1 on the top. This is a problem that I defeated the persistent people on, like Ivan. They'd be like, oh, I just draw it out. Well, Jack has 320,400 cans to stack. You could. I'll see you in 3 days after you lose count. How many cans have to be in the bottom row to make that pyramid? Are you going to start drawing? We'll wait. We're going to mass break when Ivan finishes drawing his 320,000 cans. What kind of series is this? Is it geometric, Ivan? It's arithmetic because I got 1 can in the first one, then I got 2 cans, and I got 3 cans. This is arithmetic. This 3,000 or 320,000 is the sum of cans. So we're looking at arithmetic sums. We know technically the bottom row is not going to be my A1 because I'm going to let A1 be what I know. My first row in the very tip top, so I only got 1 can. I'm going to say A1 is 1. We don't know what N is, and we also don't know what AN is. But we know what the sum SN is. So my arithmetic sum formula is N over 2 times A1 plus AN. Plug in what we think we know. So 320,400 is equal to N over 2 times A1 plus, what's AN going to be? We don't know, do we? Remember, we saw AN before with arithmetic series or sequences. Equal this. That explicit formula. AN's equal to the first term plus D times N minus 1. Well, A1 is 1. D, we add 1 every time. So I plug in for A1 and D, and we're going to get something to plug in for AN. Hold on. No, that just comes out to be N, don't it? Sweet. Here's what I got to solve. I'll show you a quicker way of doing that factoring thing. You're going to have to use a calculator for this anyway. Ready for the cheat code, Ivan? Press math. Go to the bottom. You see how it says solver? Yeah, click enter. It's got E1 and E2 on there. For E1, that stands for equation 1. Put your left side. 320,400. Then you go to E2, that stands for right side of equation. And we'll go x divided by 2, and in parentheses 1 plus x. Now I'll go to OK. We just press down arrow key, and it says x equal, mine says x equals 0. Here's what you do. Give me a guess for what you think the answer is going to be. There's no way it can be 0.59. Well, I want you to give me a guess. If for this problem with Jack, how many rows do you think he's going to have to make for 320,000 cans to add up? Doesn't matter how bad of a guess it is, just give me a guess.
Say a number.
Say a number, dude.
All right. 5,000.
5,000. So type in 5,000 where it says x equals. And then you're going to press alpha, enter, because it says solve in green above the enter button. Alpha, enter.
Oh.
I got 800. 799 and a bunch of nines after it. 800. So he had to have 800 cans in his first row. Think your piece of paper is big enough for 800 circles? Last one. All right, a tennis ball is dropped from a height of 15 feet, rebounds 70% of the height in which it falls on each bounce. Find the height of the rebound after the 5th bounce. And then we'll try to find how far in total the ball traveled before it eventually stopped. All right, so let's see. Ball starts, falls 15 feet. Hits the ground, bounces up 70% of that distance, and it falls again. And it keeps repeating this. Goes up 70%, falls again. And eventually it'll keep going until it comes to rest. How high does it bounce up after the first bounce? 10.58. All right. And then how high does it bounce the second bounce? All right. So starting with, find the height of the rebound after the 5th bounce. So that was after bounce 1, bounce 2. Continue that on and tell me what the rebound height is after the 5th bounce. 2.52. All right. Find the total distance traveled. Well, this is a geometric series. Now, technically, Do we know how many bounces it's gonna be before this thing stops? Well, we're only bouncing back up 70% of what we felt. So technically, we would never actually make it to zero. But we all know that eventually a ball is gonna come to rest. This is called an infinite geometric series. And we're gonna spend some time studying this next week. But since we did a word problem here, this is a cool little problem. Infinite geometric series have their own summation formula. Because our current geometric series, we have to know A1, R, and the number of times it bounces. If it's an infinite series, the sum of the series is equal to the first term divided by 1 minus R. Only works for the geometric series that are classified as infinite. This ball bouncing problem is. Well, if we want to find the total distance the ball traveled, we got to find the total distance of all the falls plus the total distance of all of the rebounds. So I'm going to find the sum of an infinite number of my red arrows where I fall down. Well, the first fall was 15 feet, that's A1, over 1 minus R. Well, what is R? What's R in context of the problem? 70%, so 0.7. So that's going to give me how far the balls fell in total. And then I need to take that and I need to add to it the sum of all of my rebounds, which my first rebound height was bounced up 10.5 feet. And then I go over 1 minus R again. So add those two fractions together, and that'll tell me how far this tennis ball traveled in total from start to finish. Ivan said his thumbs are tired. I get 85. You got 85 too? All right, that's what I got. All I got. Yep.